Hey there everyone, I wanted to go over all the right sides that I asked you to do. So this is just going to be one long video. I did everything ahead of time, and so I'm just going to quickly explain my answers. Alright, so this negative reflects it over the x-axis. That 2/3 makes it a vertical compression. The -2 makes it go right 2. The -3 makes it go down 3. The 9/16 made it vertically compress. The negative x made it reflect over the y-axis. The -5 made it go right 5. And the +4 on the outside made it go up 4. This one, solving it twice, set it equal to 6g. Add 3g over, divide by 9. You get 1. Do it again, but with 6g being negative, you got to make one side negative. Add 3g over, you get -3g, divide by -3, you get -3. But that answer is extraneous because when you graph it, there's only one intersection. Alright? The next one, kind of an interesting problem because when you start solving it, your 6c's would cancel. So you end up getting something that says -4 equals -12, which doesn't really work, so you're tempted to say it's no solution. But remember, you have to change one of the sides, the signs on one of the sides, kind of like on this one. So there's more than one thing, so I changed both the signs. So -6c and -4 turned into positives. And then now I'm just solving for c. So I added 6c over, got 12c. I added -4 over, got -16. Divided, I got -4/3. And that's my answer for that one. Okay, so let's go on to the next page. Alright. Here, this one was a little unusual. I'll say that much. Start off, -9. Okay, divide by -2. And you get positive 10.5. So when you divide by a negative, your two negatives cancel. That's good. That means you're not going to have a no solution. And your inequality symbol flips every time you divide by a negative. So at this point, I made my two-ended inequality. I -1 to the other side. And then I divided by -3, which means my inequalities are going to flip again. So my answers are up here. And so I kept it as a fraction because I didn't want to write the decimal answer. And so it's saying h is greater than 11.5 and h is less than -9.5 over 3. Also over 3. And that's out of order. The smaller number should be here and the bigger number should be there. So I broke it up and I wrote it as an or statement. And then it makes sense. H is greater than 11.5 or h is less than -9.5. Oh, and I should have written over 3. Yeah, fixed it there. And the graph is going in opposite directions. And so I have the 11.5 over 3 there. Okay, so this one, add 1, okay, you get 9. Get rid of the fraction by flipping and multiplying, so multiply by 3, you get 27. 2x plus 3 is less than or equal to 27. Make it a two-ended inequality. Make the other side negative though. So -3, I got -30 on one end, positive 24 on the other. Divide by 2, and you get -15 and 12. See what I mean? The smaller numbers on the left, the bigger numbers on the right. So that's how it should be. So solid dots, shade in the middle. I forgot to point out this one, open dots, because it's not underlined. And it was underlined there. Alright. This one, how did I graph these? I started at -2. Alright. And then I went up 3 over 2. Up 3 over 2, up 3 over 2, and then I did backwards, down 3 left 2, down 3 left 2, and so I shaded up because it's greater than, and I did a dashed line because it's not underlined, so that's the black shading there. And then this one I did in blue. I started at +9, and then I went down 3 over 1, see, up 9, and I went down 3 over 1, down 3 over 1, down 3 over 1. I connected it with the solid line because it's underlined. And then I shaded down, so that's in blue, and so this is the common shaded area there, and so is 0, 0 solution? Yes, it is, because it falls in that common shaded area. Alright, so that's all the answers for the absolute value one. Let's go to the next review. Okay, so solved by hand, I saw that I had 2 positive y's, so I multiplied everything by -1 on this equation. So that changed all the signs. So now I have positive 3x minus y equals positive 5, and then I added the two equations together. A plus 3 is 11, negative 16 plus 5 is negative 11, so dividing by 11 gets you x is -1, and then I just plugged in my -1 into one of the functions, so this got me positive 3 plus y equals -5. So if you minus 3 to the other side, you get y equals -8. So my intersection's at -1, -8. Alright, so 2b, what's the possible first step when solving by elimination? Well, to eliminate the y's, I could multiply this bottom one by 2. That's because this one has a 14, this one has a -14, and so the y's would cancel out, and I'd have -4x equals 14. If I wanted to cancel out the x's, I could multiply this one by a 3 and this one by a 4. Why is that? Because 8 times 3 makes 24x, and 6 times -6 times 4, equals -24x. So I thought of the smallest number that they could both be multiplied by to get something to cancel them out by. Yeah, so that kind of weird, but so the x's would cancel out and you get like 70y equals 52. So speaking of, what are my answers? So yeah, canceling out the y's from earlier, -4x equals 14. Adding 4 and 10, divide by -4, you get x is -7/2. Canceling out the y's from earlier, the x's from earlier, you're going to get 70y equals 52. So simplify the fraction, that's 26/35. So the final answer is -7/2, 26/35. And lastly on this page, write a system to represent the following graph. This line going straight up and down goes through the x-axis, so it's going to the right of it. So x is going to be greater than or equal to 2 because it's going to the right and it's a solid line. So the other one starts at +1 and it went down 3 spots and then went over 1 and then it went down, whoops, I went too fast. It went down 3, it went over 1, down 3, went over 1. So -3 was my slope. So I said -3x plus 1, and I used greater than or equal to because it's a solid line, and the shading would be on top of this line. They just had the overlap shaded area. And then, yeah, y is greater than or equal to that. Alright, next page. So, for B, solve this system. What I did here was I got everything to one side. Well, I set them equal to each other, sorry. Because y equals y. So that's why you can set them equal to each other. If a equals a, then whatever a equals, yeah, use that. So I don't like having a -x squared, so I added it to the other side. And so I minus the 4 to the other side. I got everything on one side. That ended up, I was able to combine 1 minus 4 from -3. The -2x goes in the middle, x squared's out in front. So this can factor. The factors of -3 that add to -2 are -3 and +1. So x minus 3 times x plus 1 equals 0. So x equals 3 and -1, because if you plugged in a 3 here, that'd make it go to 0. If you plugged in a -1 there, that'd make it go to 0. So those are my two x answers. What are my two y answers? I just plugged it into one of the two functions. This one's a little simpler. 1 minus 2x, so 1 minus 2 times 3 is -5. 1 minus 2 times -1 is +3. So my final answers are 3, -5 and -1, 3. Alright, so this one you had to use the calculator, convert it to a matrix. Just know that there's no y term in this middle one, so make sure you put a 0. And I got -9, -84, -13. So x is -9, y is -84, z is -13. Don't forget to do the RREF and put it in parentheses. Alright, And then I made a matrix out of this. There's nothing out of order. It goes burger, fry, drinks, burger, fry, drink, burger, fry, drink. So burgers are X, fries are Y, drinks are Z. Plug everything in. You get a weird answer because whoever wrote this problem kind of goofed up on the answers. It doesn't make sense. You pay $3.75 for a burger, and then they give you 50 cents every time you order French fries, and then you pay $3.25 for a drink. So yeah, doesn't make any sense, but that's how it goes. So a burger was $3.75. All right, next review. So write a rule for g described by the transformation of the graph of f of x squared equals x squared below. Translation of right 8 and down 19. Right 8 would be minus 8 on the inside, and down 19 would be minus 19. So this function is reflected across the x-axis, so I put a negative out in front. Shifted 5 units left, that means I'm going to add 5 to the inside. So that's 8 plus 5 is 13. And then 4 units down, I'm going to minus 4 on the outside, so that's plus 3. 3b. The vertex of a quadratic function is negative 5, negative 2. Write the quadratic function with this vertex. So in the earlier one, this was the formula. Plug in everything for h and k, and you just flip the sign for the h basically. X plus 5 squared minus 2. Translate it 2 units left, so I'm going to add 2 to the inside, so that becomes x plus 7. And then 4 units up, so I'm going to plus 4 to negative 2, so that makes it positive 2. Alright, 4b. Identify all these attributes. So the vertex was here at 2, negative 3, so the axis of symmetry is x equals 2. The minimum point was down here at y equals negative 3. The domain is all real numbers, and then the range is, since it's going up, is y is greater than negative 3, or you could say negative 3 in a bracket, comma, infinity in a parentheses. So on this one, without the graph, y equals x squared plus 8x plus 12, it's in standard form, so you had to do your axis of symmetry formula, negative b over 2a. I wrote it down right there. And my axis of symmetry will end up being negative 4. And so, got to plug it in. Negative 4 squared plus 8 times negative 4 plus 12. That'll give you your y answer, which will also turn out to be negative 4. So my vertex is at negative 4, negative 4. My axis of symmetry was negative 4, x equals negative 4. My y value was negative 4. And I wrote a minimum point because that a was positive, so the graph is going to open up. Something you can verify by typing it in and graphing it if you're ever unsure. So that's why I put minimum. Domain's always all real numbers for quadratic, and then since it's opening up, y is greater than or equal to negative 4 for the range. Number 6. Find the focus and directrix for the following equation. Okay, so comparing it to this, see how the formula is x squared equals 4py, and the directrix is y equals negative p, the focus was 0, p. Everything flips because it's different letters. It's y squared equals something x. This one was x squared equals something y. So yeah, here, look at them side by side. Maybe that makes it easier rather than me moving it all around. So I had to get it to y squared equals. So y squared is going to equal 4px. Here's the formula here. X squared equals 4py. So I just divided by 4, and I got y squared equals 4x. So 4x will equal the 4p. So it's got to be p is 1. Once you know p is 1, like I said, the focus flips since your letters flip. So p, 0, 1, 0. And then it'll say x equals negative p. So x equals negative 1. And then I did write that down there, but it's kind of small. So yeah. 7b. Write an equation in vertex form for the following graph. Alright. There's your vertex, so that's hk. There's your x and y. Plug everything into the vertex form. The a times x minus h squared plus k. Plug everything in there. So I did 1 equals a times 2 minus 0 squared plus 3. This will make 4. 2 minus 0 is 2. 2 squared is 4. 4a plus 3 minus 3 to the other side. You get negative 2 equals 4a. Divide by 4. You get negative 1/2. So your function, since it's x minus h, right? So it would be x minus 0 squared, since h was 0. So I don't have anything in parentheses, so that's why it's just negative 1/2 x squared plus 3. B, it also says in vertex form, but this that's just a little bit of a typo. It's in intercept form right here, so I just wanted the answer in intercept form. So I plugged in everything. It's the intercept form is the a times x minus p times x minus q. So you just had to minus these two, p and q, in there. And so I ended up getting negative 0.25a equals negative 0.25 divided by itself gets you positive 1. And I wrote negative 1. So I'm going to correct that right now. It's positive 1 because two negatives would make a positive. So positive 1, positive 1. So that's all it is. It's technically the graph is x plus 4 times x plus 3. So, yay, glad I caught that. Alright, next review. So unit 4, consider solving by completing the square. All you have to do is b over 2 squared. So that's negative 8 over 2 squared. That makes 16. So the factors of 16 that add to negative 8 are negative 4 and negative 4. So I wrote x minus 4 squared equals 14 plus 16 is 30. So now I'm going to solve one by completing the square. Got to get everything to one side, or at least this middle x term to the other side. So add it over. X squared plus 8x plus 41 equals 0. That's not a perfect square trinomial, so I minus the 41 over. And then I add in me completing the square. So I added in 16 because that's 8 over 2 squared. So I added 16 to both sides. The factors of 16 that add up to 8 are positive 4 and positive 4. So x plus 4 squared equals negative 41 plus 16 is negative 25. The square root, the next step would be to square root both sides. The square root of negative 25 is plus or minus 5i. The square root of x plus 4 squared is x plus 4. So I just had to minus 4 to each side. And I got x equals negative 4 plus or minus 5i. 3b. Find the sum. So I just wrote it, and I put a plus sign in the middle. That's all I had to do. Add like terms. 3 plus negative 2 is 1. 9 plus negative 4i. 9i plus negative 4i is 5i. That's it. That's the answer in standard form. 4b. Square root both sides. Square root of 13 doesn't simplify, so it just says plus or minus square root of 13, minus 5 to the other side. X is going to equal negative 5 plus or minus square root of 13. 4b, express this in standard form. So 1 times 3 is 3. 1 times negative I is negative I. 9i times 3 is 27i. 9i times negative I is negative 9i squared. So I could combine these two to make 26i. And then negative 9i squared, well, that can turn into negative 9 times negative 1, because I is the square root of negative 1, so I squared is just negative 1. It would take away the square root, and the square would just be negative 1. So negative 9 times negative 1 is positive 9. So then I could add these two together. 3 plus 9 is 12, so the final answer is 12 plus 26i. Alright, next page. If the discriminant is positive, you'll have two real solutions. The formula for the discriminant, I mentioned it in this video right there, see, was b squared minus 4ac. And that's it. Solve the equation by completing the square. Okay, we did one earlier. Minus 3 over, because it's not a perfect square trinomial right now. So you have x squared plus 6x equals negative 3. Got to complete the square now, so I'm going to add in 9 to each side, because that's b over 2 squared. 6 over 2 squared is 9. So I added in 9 to each side. The factors of 9 that add up to 6 are 3 and 3. So x plus 3 squared equals 6. So you got to square root both sides. And that'll be the square root of, this will equal plus or minus the square root of 6 because it won't simplify. Then you can just minus 3 over. Final answer, x equals negative 3 plus or minus the square root of 6. 7b, all you had to do was type it in the calculator, do that menu 6-4, and yeah, that's what I got. -4, -2, and -2, -2. Simple as that. 8b, solved by factoring. You needed to change this to a plus 35, and then the factors of 35 that add up to 12 are 7 and 5. So x plus 7 times x plus 5 equals 0. So what two numbers would make this go to 0? A -7 or a -5. Yep. And the last one, solve, write the answer in simplest form. Okay, so -32, how can I simplify that? Well, 32 is 16 times 2, or -32 is -16 times 2. The square root of -16 is plus or minus 4i. The square root of 2 would stay behind, or stay as is, I should say. And then I can multiply these two. -2 times plus or minus 4i would become plus or minus 8i, with the square root of 2 next to it. 75. Well, you can say that that's -25 times 3, the square root of -25 times square root of 3. Square root of -25 is plus or minus 5i. The square root of 3 just stays alongside there. So the final answer is plus or minus 5i times the square root of 3. Alright, almost done. On this graph here, by the way, in the first video, I don't think I pointed out the transformations on this first one. This 2 is a vertically stretching this. This plus 2 made it go left 2, and this minus 8 made it go down 8. See? The vertex goes left 2, down 8. And the graph would look a little bit skinnier than another graph without that 2 in front of it. So this one, the negative makes it reflect over the x-axis, the 2 makes it vertically stretched, the 3 makes it go up 3. And then for the vertex, you see the vertex here at 0, 3, so the axis of symmetry is x equals 0. The maximum point is at y equals 3. The domain will be all real numbers. And so since it's going down forever, I say y is less than or equal to 3. Or you say -infinity, comma, 3 in a bracket. -infinity is in parentheses. Alright, so 2 and 3. Well, 2, it went down 6. That's a transformation. So my range... I wrote my range wrong. I'm just realizing that right now. My range is all real numbers, so don't look at that. The range is all real numbers. And, yeah, why is that? Because it's going up and down freely forever. Okay? And, yeah, but the domain is all real numbers as well. See, why would the range be different from this one? That we did right next to it. That's also a linear function. So, yeah, kind of a bozo mistake. But 3b, graph the transformation to its parent function. Okay, yeah. You had to change this to a plus 1 because it was the exact same thing as this one. So changing it to a plus 1 made it go up 1. The range is y is greater than or equal to 1. The domain is all real numbers. Next page. Alright, so this made it go up 4. You see it started at 4 up. The domain's all real numbers. The range is y is greater than or equal to 4, or 4 in a bracket, comma, infinity, parentheses. 5, graph this transformation. Okay. The 1/2 made it vertically compress. The -6 made it go down 6. So here it is down 6, and it looks a little bit wider than it should. And so this is the range, -6, comma, infinity, or y is greater than or equal to -6, and domains all real numbers. And the very last one, 6b, identify and correct the error in describing this. Well, it says the graph is translated 3 units right of the parent function of the parent absolute value function. Yeah, 1, 2, 3. Yep, it went 3 to the right. So the function is f of x equals x plus 3. No, if you graphed this that they originally had, it would start over here, 3 to the left, because remember, it goes opposite when it's moving left or right. So if you think, oh, it's going to move right, you're going to have to minus 3 on the inside of the function. So that's why I wrote f of x equals the absolute value of x minus 3. And that'll wrap this up. Thanks for watching.